All right, so we are going to cover joints today here in week 4. And basically what joins do are they're going to let us tie multiple tables together horizontally. So that's kind of what I like to think about, back to kindergarten when you learned which way to fold the paper. We have horizontal, which is like hamburger style, and then we have vertical, which is like hot dog style. We're going to kind of do that same thing, but we're going to be folding some data together. So I'm just going to kind of just jump straight into the basics. Feel free to stop me at any time if you have any questions. But yeah, I'm just going to start from the beginning, just in case there's an understanding someone hasn't gotten to. And I also like to start at the beginning because we kind of get a build up through to see all the options. So the first thing that I'm going to do is actually show you an old way of doing joins, which is kind of most people would think, that's counterproductive. And I used to actually think the same thing, like, well, why is it necessary for us to learn the old way of doing joins? Because I have never seen one out there in the real world myself. But then I kind of came to the conclusion, like, oh, it's actually kind of nice because you get to see why the new way is actually so nice. So that's where we're going to start. So let's take a look at our tables and see who we're going to play with today. So let's take a look at our film and film actor and our actor table. So we're going to kind of do 3 tables here. So we're going to do film. Actually, let's start with something easier. Let's go from, take a look at address. Okay, so address has a city ID in it. So that's probably what we're going to use just to get started. So that way I don't over confuse you from the beginning. So if we do our select from address, we can see that inside of this table here, we have this city ID, and you'll notice that it just has numbers. It doesn't mean anything to us. Like, oh, I want to know what city these people are in. I can see they're in California, but what city? And we can go and look that up and say, okay, let's select everything from city where city ID is equal to 449. We can say, oh, they live in San Bernardino. But that's not very user friendly, because like most of the time we want to kick out these reports on the fly, and other people are going to be using these and that kind of stuff. So what we're going to do is we are going to perform a join, because really what we want to see is we want to see some various information from that. We want to see all this information from address, but with the city there. Like we want to see the city, state, and zip, for example. So let's start off on that understanding. We want to see their address, the city, the state, and the zip code. So let's start off by selecting our address. And we don't have city yet, but I'm just going to put a placeholder there for now. And then district and postal code. And I'm actually going to put whenever I do joins, especially like if I'm still experimenting or verifying, or maybe it's the first time I'm doing it, I like to actually put the ID columns there, so that way we can kind of see what's going on. So let's go ahead and run this. And now we kind of have some of our data here in front of us. But like we said earlier, we want this city column to be actually have the city in it. So like I said, I'm going to show you the old way of joining first. Okay, and the old way of joining is pretty simple. We just put a comma and say from address, comma, city. Now, if I go ahead and run this, it actually is going to fail because it says column city ID in field list is ambiguous, which means that, hey, city ID actually exists in both these tables. Like, which one do you want? So in this case, we have to give our tables names so that they know which column we are pulling it from or where we're getting it from. So there's two ways to do this. The longhand way is actually to put the whole table name in front of the columns. So basically, this is all of our address information. So I put the address dot column name there. And now I can run it and get some data. But now we have another set of problems because you'll notice that this address, 47 Sql Drive, is actually in here a lot. We have like a lot of results. And so we duplicated records. And I know someone brought this earlier and that they were wondering, or they still were confused about what a Cartesian product is, right? So what the Cartesian product is we actually multiply the two tables, meaning that every address now is connected to every city, meaning that, Sql Drive is going to be listed for every city. And so let's actually try that here. So I'm going to do city dot, what is the city column? It's city.city. I can take out my alias now. And so this will actually show us how it's connected to every city. So you'll notice that Sql Drive has pretty much every city, right? And that's not what we wanted, but sometimes it is what we want, right? For example, if I wanted to, let's say we want to come up with a data set that will show us every possible die combination. So I guess just really fast. Let's see how fast I can type. Let's select 1 union all, select 2, 3. Let's just try this real quick. Right. So for example, if I wanted to build a table that had, let's say it's a 3-sided die, right? Just to make things simple, I have 1, 2, and a 3. Now, if I wanted to create every possible combination, if I had 2 of these dies, I could do a join. So I could say select everything from, and I'm going to call this one D1, and then I'm going to do a join with the same thing, just again. We're going to call this one D2. Now you can see that I actually have every possible combination. I have 1, 3, 1, 2, 1, 1, 2, 3, 2, 2, 2, 1, 3, 3, 3, 2, 3, 1. We actually took and multiplied those together, and we can know exactly what the outcome's going to be because we just multiply it. So if this table has 3 rows and this table has 3 rows, then we know we're going to end up with 9 columns because it's just going to multiply them, which in this case we do. We end up with 9 total records. Sorry, I think I said columns, 9 total rows in our table. And so that's what we're doing here with our addresses and our cities. We're multiplying the two tables together to get the Cartesian product, also known as a cross join. And this is the old way of doing it. And in fact, I'm going to put a comment up here that says Ansi 89 standard, because that's what that is. So if we wanted to do a cross join in the Ansi 89 standard, this is how it would be. But what we want to do is we only want the city for our address. So how did they do it back in the old days? Well, with a good old fashioned where clause. And we say where address dot city ID is equal to city dot city ID. So basically we get every possible combination that's possible and then reduce down to exactly the result set that's accurate in this case. So if we run this now we're actually going to get what we were looking for. And now we can see all of our various addresses. Like for example, let's take a look at our, let's look where district is equal to California so we can, and address.district is equal to California. There we go. So now looking back at our San Bernardino, address. Now we can actually, instead of seeing the city ID 449, we can actually see San Bernardino. And now we can, kind of clean up some of our stuff. And to show you how that join work, basically anytime all of our tables have a primary key and a foreign key. So inside of our city table, we have our primary key, which is city ID 449. And we link that to the address table. So in the city table, it's the primary key because it uniquely identifies each row. But in the address table, we could have multiple addresses in the same city. And so how do we link that address to a city? Well, it's called a foreign key because city ID doesn't belong inside the address table because we already have a city table. So that's kind of how I like to remember it, is the only time that we should ever overlap data is in primary and is in our foreign keys. The primary key from the city table is the only thing that should be a city related item in any other table, because that's what makes it, you've probably already read a little bit about first normal form, second normal form, and all that fun stuff. Well, that's how you get to, have good data, is because we want to isolate our data. And the only time that we should ever have two values that are like the same meaning should be in our foreign keys. All right, so that's the old way, where we have we take every possible combination and then we use the where clause to filter it down. Now, I'm going to divert here and talk a little bit about the order of how Sql runs these queries, which maybe it's already come up, maybe it hasn't, but just as review because it is relevant. So when the computer actually executes this query, it doesn't start with the select statement. It actually starts right here in the from clause. So it's going to start at the from clause and gather all the data. And so in this case, it's going to get all the address information, all the city information, and it's going to get every possible combination there. The second thing that runs in any select statement is the where clause. So now we got to think about this from a performance standpoint, because for us, it doesn't matter. We can see that this query took 42 seconds, or 0.000042 seconds. So, very fast. But it becomes very prevalent when you're Facebook or Google and you have huge data sets and you have limited resources on servers. And so, and it could be even in my work, I've come across times where a query can take upwards of 30 minutes to run, one query, which obviously isn't ideal, especially when you wait 30 minutes to find out like, oh, I missed something or whatever. And so we want to be as efficient as possible. And this is a process called Sql Tuning, but that's kind of the black magic sector of it, but it's important to understand the way it works just so we get there. So because we loaded up both these tables and multiplied them, all that data takes up memory on servers, memory on your computer. Like, because, we run our databases locally on our machines. And, for us, it's not a big deal, but you can imagine if we had, 5 million records in each table, all of a sudden we're talking about 25 million records on or 25 million times 25 million, whatever that turns out to be. It's a lot. But I don't even know what it is. But it's a lot of data. And all that data has to sit somewhere while the computer's doing this, because anytime we run a query, it has to hold all that information somewhere so it can work with it. It can sift through it. So once the from clause executes, we have all the data sitting in our RAM or our memory, and which is a finite resource. So then it has to sort through it. And at that point, it can release some of that memory into the wild. But for that initial from clause, we have a ton of it. And then finally, the last thing that runs is the select statement, which basically is where it condenses it and actually only outputs what you tell it to. Now, this doesn't free up any memory necessarily because it's technically all in the background, but once it spits it out, it's done. So really the select. Once you get to the select statement, as far as memory goes, it's pretty much over. But that's why that's the 89 standard way of doing things. So now let's flip to the new way, which is the Ansi 92 standard. And in the Ansi 92 standard, they kind of said, well, there's got to be a more efficient way to do this, because I don't want to load all this into memory necessarily, or we just want to be more efficient with it. So I think that's what they did. So I'm actually going to take this and show a couple shortcuts. So I'm going to first just let's copy it. And I'm just going to make one minor change, and it's going to be Ansi 92. So instead of doing this comma, I'm going to say inner join city. Now at this point, I can run this and we get the same results. It means the exact same thing, and I can take out my where clause. Sorry, I forgot that step. So now it's Ansi 92. Let's see, fix this. There. Now it's Ansi 92. So you'll notice that by adding the inner join, we took out the need for this where clause filter. And the reason being is because with our inner join, that's built in. That filter is actually kind of built into the from clause. And I know I sent this in the announcement. I'm sure you've seen it before, but there's this really, really nice diagram. These Venn diagrams that show you the various joins. So the main one, my favorite one, is the inner join. Well, my favorite one, the one I use the most is the inner join. But there's also left joins, and we'll talk about each of those. But where we only wanted the matches, we use the inner join. So you can see here, table A is address, table B is city, and it's just what determines what's A and what's B. Well, it's just the order. We selected from address first, so address is A and city is B. But we only get the matches in between. So we get everything from, we get all the addresses that have a matching city, right? If we had a address that didn't have a city, it wouldn't be in the list. So that's just one thing to keep in mind, that you might filter out some records that way. But what makes the Ansi 92 standard more efficient is because this all executes in the from clause, it can sort through it on the go. So we only get the results. Instead of multiplying everything and then filtering it, we kind of just get it filtered. So instead of having, like in the example, the 5 million rows per each table, instead of having 5 million times 5 million, we just have 5 million, hopefully, or less. But there are times where you may not want to use an inner join. You may want to use something different. But anyways, I'm going to show you one more little shortcut here, because it will save you typing. So you'll notice that I typed the full table name. Well, we can give these tables shortcuts, right? We can say address A and city C. And then instead of having to type the whole name, we can just give them the letters. Basically, they're like nicknames. They're called aliases, table aliases. And they're just like little nicknames. So that way we don't have to type the whole word. So these two queries are exactly the same, just all done a little differently. So you'll see me use table aliases a lot, because that's probably the preferred way. I really don't see too many people that actually type the whole table name, especially when they're just working on the go. Any questions up to this point about the two Ansi 8992 standards? We're going to jump into the difference between inner, left, right, and all that stuff. But just wanted to pause and take a minute. Does anyone have any questions about Ansi 89 versus Ansi 92?
I have a question.
Sure.
Where does the on statement come in?
Oh, I'm so glad you brought that up.
Use it either time.
Yes, I actually just straight up forgot that. So that is the key part of the inner join. So I was still doing a cross join at this point. What we want to do, like you said, is we want the on clause, because that's what's going to determine how we match. So, and in this case, what's really nice is it's the same thing as this where clause. The only difference is that it just the order in which it runs. So really, you can just take that and pop it in there and do the same thing here. Yes, I'm glad you brought that up. The on clause is very important. And the on clause, what that does is it just determines how we match up, just like we did on the Ansi 89, where, we had every possible combination. Well, we really only want the city where, I only want the city that I've linked to, right? And the computer won't do that automatically for us. We have to tell it, which columns do you want to link these to on? And we can use multiple columns, but if your database is built right, for the most part, we should only need one. And so in this case, we have our two, and away we go. And so we now have our city and city. And a good way to kind of check that is I can actually just go like this, add both columns, and I'm just going to say as address, city ID, and then as city ID. And you can kind of see how that logic works, because basically it just matches up the two cities together. So if this address has address city ID or has a city ID of 120, that's the city ID it's going to link to, which is Citrus Heights. Thank you for bringing that up. I would have totally missed that. Perfect. All right. So let's continue on. I'm going to shove this down to the bottom of the page here. So we're going to talk a little bit about left join, right join, and all that kind of stuff. So let's switch over to using film actor, and the actor table. So let's start off, and we're going to join multiple tables together here. So in the previous example, we did 2. This time we're going to do 3 tables. And so I'm going to start, and this is kind of the way I actually build the queries when I'm working. So I'll start off with my first table. So I'm going to select everything from film and take a look. And I know that I want to connect this to actor. And, I have my list of tables over here, but, I can kind of look through this and say, okay, yep, here's all this. Looks good. Film ID, yada, yada. So I'm going to call this F. Now what I'm going to do is I'm going to, and here's an interesting thought, which is why you got to be thinking as you're doing this. And there may be films that don't have actors, right? Like, let's say it'd be rare, but it is possible, right? Like, let's say that it's a silent film and it doesn't have anyone in it, but it's just animals. There's no voiceovers. Like, really all you had was a producer. So we're going to be conscientious of that as we build this query. And instead of doing an inner join, we're going to do a left join, because we want to know all the films and any associated actors. And if a film doesn't have an actor, we want to keep it on our list. If we used an inner join, we would exclude it, which hopefully we'll demo here in just a minute. I'll actually do the flip of this and we'll get all the actors in the film they're in. All right, so this is a good example of, when I'm on IMDb looking at a movie and it shows you like the list of actors at the bottom, or if I'm on Netflix, it shows you the list of actors in the film. This is a query that might run for them. So let's left join this with film actor. And the reason I like to show this example is because we kind of have this in-between table, because we can't necessarily go straight from film to actor, because actors, the actor table holds like single actors, like Will Smith, and the film table might hold, iRobot. But a film can have multiple actors. So this middle table, this film actor table, acts as like this is the bucket that you throw all the actors in. It lets you group many actors together by film. So left join, and we'll cover that more because I'm hoping that we have enough time that we can get to a quick demo of a final project just to kind of help you wrap your head around some of these design concepts for your final projects. So what are we going to join this on? Well, let's take a look at film actor. Select everything from film actor. So this is where I like to just look in the table and say, okay, what do I got here at my disposal? Well, I have film ID. I know that film has film ID, so that's probably the path I want to take. So I'm going to go f.filmid is equal to fa.filmid. Kind of like tunneling, connecting. I'm basically drawing, a line from here to here and moving, I guess you could say. Okay, so now I have film actor. And now I want to left join again because we may not have films. We may have films that don't have actors, and we're going to join that to actor. But let's run this real quick. So we're to this point. I'm selecting everything. We'll actually see it all. If I were to run this, I can see movies now and the various actors or film actors in them. So if I go over here to film actor stuff, for film ID 1, you can see that we have a few different actors, right? Quite a few actually. And we can see that this is working. And you'll notice now that not only do we have access to all the film record columns, but we have access to all the film ID columns. And film ID has this nice little actor ID column. And so now we have a way to get to actor. We have an avenue. So we're going to say left join actor. Call that A. We're going to say on. And just like we looked, well, film ID or film actor has an actor ID column. So we're going to join to actor on film actor. Actor ID equals actor.actor ID. And now when we run this, now we can kind of see the full gamut here. And we can see that Penelope Guinness was in this movie and, so on and so forth. So now we can see the actors. So I like to do that so I can kind of see like across the board, and then we can kind of clean it up to where, okay, what do I want to show? Well, I want to show the film.title. I want to show the film.description. Thinking like kind of what they show on Netflix. So, they show the release year. We're going to ignore price since we're pretending that it's, the length of the film. And then we want the actor name. And let's combine those up. So we're going to say concat a dot first name space and then a dot last name. And there we go. So now we actually have the title of the movie, the description, the release year, the length, and the actor name. All right, cool. So now let's flip this the other way. And I want to know, well, I guess it's really the same thing. It really doesn't matter too much. We have, in this scenario, we have all of the films, whether or not they have an actor. So let's actually see if we have any non-matches. And I can do that just by saying where the actor ID is null. Because if it didn't match, it's going to be empty, right? So look at this. We actually do. We have some films that don't have actors, which is pretty crazy, actually. So you can see here that we have that sounds like a very interesting movie. An insightful panorama of a monkey and a sumo wrestler who must outrace a mad scientist in the Canadian Rockies. Anyways, we have a few movies that don't have actors. So that is why we did a left join. Now, just to kind of show you the repercussions, had we done an inner join, is they disappear. And it's not just because of this. If I got rid of this, we wouldn't even have those films in the list, which, if we would go to find them, we couldn't. But because we do a left join, they will be there. And if you want everything from film, because it was the first one, you kind of have to use left join all the way through. Does that make sense to everybody why we use that left join in this case? So this is our example of the left join. And it's because we want everything from film, right? So our first join to film actor, we want everything from film and only the stuff from film actor if it matches. And then furthermore, once we get to that point, we want everything from film and film actor, even if it doesn't have a match in the actor table. So that's why those little Venn diagrams are kind of nice. Any questions on that?
Yeah, so I have a question. It's actually from the reading quiz, and I don't know if I'm just having a brain fart and I can't figure it out. I'm already done with the quizzes, but I just want to know how I would type this into my SQL workbench, because I assume that the questions that it's asking us, like the following queries, those we can put into my SQL workbench, right?
Yep.
So can you go over one of those to like show me how I would type them? Because I just could not figure it out, and I just had a lucky guess on that one, but I just couldn't figure out how to type it. I keep getting errors on it.
Got it. Go over one from this week. All right, so like this, for example.
No, like the Harry Potter one was the one that I had.
Oh, gotcha. And there may be some examples that don't have, like, because we don't have the tables in our database, they may not work.
I think that's what this is the error that I got. It says unknown column. Is that why?
Yeah. Yep.
Okay. I was just making sure I wasn't typing it wrong, because I was like, I have no idea.
Yep.
Okay.
All right. So that's the left join. So now let's say we wanted to, the different left joins and right joins do the exact same thing. It's just the other direction. So let's say we wanted to see all the actors and the films they're in, whether or not they're in a film. And we're just going to read this a little backwards, but here's all of our actors and the films they're in. And we could even sort this by actor name, order by A dot, sort by actor name. There we go. And let's see if we have any actors that weren't in movies. That should be really weird again, but you never know. So we're going to look for where f.film ID is null. All right, so no actors that have no movies, but we're actually going to do, so I'm actually going to put an actor in real quick. So let's put in, we don't care about actor ID because it should be automatic. So let's put in our first name, which I'm going to put in myself. I'm a terrible actor, but I would hope the last update they can just calculate. They have it built in with a default. We're going to try it. All right, so now I'm an actor. So let's see if we get it. And so now we can see that, oh, I haven't been in any movies. And so that's why the right join. So we get we just switched the direction. So before we had left joins, so we got all the films, whether or not they had an actor. But when I switch this to right joins, now I get all the actors because we're going this way from the bottom up that don't have films. So left joins and right joins are the exact same thing. They're just directional. I usually use left joins. The only time I ever use a right join is just to make, like maybe I've already written it and I just want to real quick swap it just like we did here. So not very frequent that I do that, but they are the same thing. All right. And we did show an example. So just to go over some of these other ones, you know, oh, we wanted to get all the films that didn't have actors. That's what this outer is. Or the left outer, right outer. And we can even do a full outer and basically get all the non-matches. So a full outer join is basically everything. I don't care what it has. I just want all the rows. So in this case, let's actually, I think you guys get the picture. So in the full outer join, I would show up. We would also get that movie about the monkey and the sumo wrestler running around in the Rockies with the mad scientists. They would all be there. They'd just be all the columns, and most of them would be null, that kind of thing. So anyways, that's joins in a nutshell. Does anyone have anything? Oh, I know that a question came up earlier where someone wanted to see a self join. So in the exercises for this week, there is a question number 3 that talks about getting all the addresses that are in the same city, which it is a little weird because we think all the addresses in the same city, we think like, oh, here's the city, here's the list of addresses. Well, in this case, actually what it's kind of wanting is it's wanting all of the cities that are in the same city, if that makes sense. Which I know is exactly what I asked for, but basically every possible combination of city that's in the same city. Example. So let's just do that. So I'm going to select everything from address. And I was telling, let's see, I think it was Ellie who asked the question. That self joins are probably are one of the more difficult concepts to wrap our minds around, because it's pretty easy to say like, oh, here's all my films, here's all my actors, and film actor kind of lumps them together. I'm just going to join through these and get to the result. But for some reason, when we talk about joining a table to itself, things get really weird. But the most basic concept that helped me wrap my head around it is the fact that we just create copies of itself. Because, I talked about how the computer or the server will load that data into memory. Well, it can just load that data into memory again as a duplicate, which is exactly what we're going to do. We just have to give them different names. So we have our address here, right? So we have our address, and let's say we want to get all the addresses that are in the same city. So we're going to call this address 1, so A1 for short. And I'm going to select A1 dot everything. So we get everything from address 1. And I'm going to do an inner join on address A2. Right? It's kind of weird because it's like, oh, we just joined a table to itself. But just picture it as an exact copy, right? And this is actually helpful in many instances, like, for example, the one we're doing right now. And how do we want to join these? Well, we want to join them where the city IDs are the same. So let's say on A1.cityID equals A2.cityID. Right, so here's all of that first address information. We don't have anything from address 2, so let's go ahead and add that. Just go ahead and add everything. So now we have all of our copies replicated. Now, just to clean this up a little bit, because we don't care about a lot of this, I'm going to slim this down. And from address 1, I just want the address ID, the address. I'm going to call this as Oops. And let's see. So we got the address, and I want the city ID. There we go. So now we have our address, city, everything, and I'm going to do the same thing here. So let's just make this easy on ourselves. Copy this. And go ahead and run it. Oh, and it looks like I messed something up. Oh, underscore would help. There we go. So now we have all the addresses that are in the same city. But there is one thing that I want to point out, and that is this right here. So you'll notice that my Sql Drive, it lists itself. Now for the exercise, I don't think that it cares that much. But like logically, if we want to have a list of all the addresses that are in the same city, or all the different combinations, we probably don't care to see that, oh, this city is in the same, this address is the same as itself, right? Doesn't make any sense. So I'm going to add one little where clause, or we can even do it in the join. Let's do it in the where clause, where a1.city, a1.address ID does not equal a2.address ID. So we don't care about the records where they equal themselves, right? That's essentially what we're getting at. So now if I do this, we still have the MySQL Drive over here, but we don't have it when it equals itself. Wow, and that's actually a short list. So we only have a few addresses that are in the same city as each other. So we have MySQL Drive is in the same as Workhaven Lane, and we can actually see the flip of that right here. So on and so forth. Now, I guess a use case for this, if you need help wrapping your mind around this might be helpful if, per se, let's say you were wanted a quick way to kind of look up and say like, oh, these are all the other addresses in my, like, let's say we're at Video Store at 47 MySQL Drive. Let's say that they don't have the movie Hunt for the Red October. But maybe we want to look and say, oh, well, these are some other stores in the same city that you can go check at. So that might be a good use case, right? That's self-join right there. And I think, Ellie, you were the one who asked the question. If not, I apologize. But whoever asked the question, does that help? Does that help it make a little bit more sense?
Yes, that helps a lot. Chris was helping me last night, and we were trying to figure out why we had a couple repeating, like you said, the reverse. So then we were trying to get rid of that because we were like, okay, but this is the same list multiple ways. So I think I personally was just like, how do I then get it to just show it one time? And I think Chris came up with a pretty good solution for that. But I think that's what really threw me off as we were trying to do this, is just having multiple of the same thing come out.
Yeah, and as far as excluding those ones, like for example, MySQL Drive and the Workhaven Lane, like, because here's the inverse of that. Mm-hmm. That's actually, I would say that's actually okay, because most of the time when we're looking at this, because from a big picture standpoint, like I said, for that one scenario, like I said, where hey, we want a list of, if we're at 47 MySQL Drive, and I want to see, oh, what are the other video stores in my city? We actually wouldn't want to remove this record. Mm-hmm. If that makes sense. Mm-hmm. So because then if someone was at Workhaven Lane, they wouldn't see my Sql Drive as an option. So most of the time, because like I can't think of any time like we just kind of like want this as like a plain Jane list. So anytime you do a self join, context is very important, and the context is that like, okay, table one is most of the time, I guess, your scope, which is like, that's my home base. So I'm comparing table one to table two, not necessarily like this exhaustive list, if that makes sense.
Sure.
Because actually eventually we'll get to a place where we'll do set operations where we'll actually build lists. Because like right now we're working horizontally, which is adding columns. In a future week, when we deal with set operations, we're actually going to add rows, which then I think would be perfect. Like then we would want to get rid of the duplicates because we wouldn't want MySQL Boulevard to show up twice.
Right.
Yeah, but that's awesome. I'm glad you guys came up with a solution. I'm trying to think.
The context always helps. Just having a little bit more context of why would I need this? That always helps.
Yep. I've found that it always like this example is one like that. I think if you're just reading it, it's kind of like, oh, this is weird. Why would I? But yeah, there are times normally when we do self joins, it's kind of a similar. So let me actually check because I want to say select everything from actor. One thing, this is usually, okay, so I'm actually going to real quick build a table just to kind of reinforce this just a little bit. So I'm going to create a table called system user in Sql, and basically it's going to be pretty simple. I'm going to have a user ID, which is a int primary key auto. All right, I'm going to have an email with a varchar of 60 length, not null, and then I'm going to have a password varchar 255, which I'm going to let it be null for right now. And then I'm going to, so there's these things called who audit columns. So in this case, I'm going to put created by. It's going to be an int, and I'm going to actually leave that nullable right now. And I'm going to say created at, which is a date time. Last update by, and updated at date time. I'm just doing this to make it easy on myself here for a minute. Okay. All right, so these are called who audit columns. The created by, created at, updated by, updated at. And they're called who audit columns because it tells you who did it and when. Basically used for audit tables, especially in security realm, like our system user table, it's very important. Most well-built databases actually have this on pretty much every table. And the reason being is because then you can track who did things. So I'm going to real quick refresh this, get our system user table, and let's just do a quick insert. Insert into system user. I'm just going to put my columns here. So user ID, actually we don't need it. Email is all we need. Created by and updated by. We're going to put our values in here. I'm going to say Bilbo Baggins at gmail.com. All right. So I inserted that in there, and there's a reason that I had to insert it first. So now if I select everything from system user, we should see Bilbo Baggins. Doesn't have a password, which is irrelevant, but created by one, created at, updated by one, created at. Perfect. But now what I'm going to do is I'm actually going to change my table. And I couldn't do it before because we wouldn't be able to put data in there. But I'm going to tell the system user table to reference itself, right? So I'm going to tell the system user table that, hey, because what we want to do is we want to track who created this user. And this is why I said context is important, which I'll reiterate here in a minute. So I'm going to alter the system user table. And I'm going to add constraint. I'm going to add a constraint to basically make it so this created by references itself. Created by. That's I guess we need to make it a foreign key. Okay, system user. I'm messing up all my own naming conventions here. Foreign key. And the foreign key is on created by. And it references system user, user ID. There we go. So there's that first one. And I'm actually just going to kind of I'll copy it so we have a reference. And I'm going to make a second one, but instead of created by, it's going to be updated by. All right. So now if I were to do a diagram, an ERD, this system user table would actually have two lines that just circle back to itself, if that makes sense. In fact, I'm going to refresh this real quick and let's actually do that. Tool, database, reverse engineer, CIT225. We're going to go next. Right. I'm going to do Sql because that's what I did. Next. Sure. All right. Now let's find our system user table. It should be all alone over here by itself. All right. And like I said, you'll actually see that it has two little lines that circle to itself. Created by references itself and updated by references itself. And the implications of that now, so if I select everything from system user, now you can see that in this case, Bilbo Baggins created himself, which, you know, had to be. Someone had to be the first, right? In this case, it was Bilbo. So let's go ahead and I'm going to add a couple more people here, and just so we can have this for the sake of saying that we did everything. So Bilbo Baggins is now going to create someone else's. So they log in, they're like, hey, we just got this new person. I want to give them access to our system and create them a login. Frodo, you're going to become part of the family business, right? He's created by and updated by Bilbo, right? So he creates Frodo, and let's say, Sam Wise Gamgee, you've always been part of the family. I'm going to create you one too. So now we have a few system users that were all created by Bilbo, right? But let's say now all of a sudden Frodo's like, oh, Bilbo didn't want to create Pippin and Merry an account because they're little ruffians, they're just going to break things. So instead, Frodo creates Pippin one, right? But the nice thing is that in our web interface where they do this, it tracks who created them, unknown to Frodo at the time, as it happened. So I'm going to put 2 here just because that's Frodo's. In fact, well, let's do it the right way. Select user ID from system user, where email is equal to Frodo@gmail.com. All right, we'll do this the right way and use a subquery to pull our value, so we're not hard coding anything. All right, so there's that. So what did I do? You can't specify table for update in from clause. I've never actually done this on my SQL before, but apparently it doesn't like it. So we're just gonna go back to this for now. I know that's possible. I'm probably just missing something. All right, so now we have a Pippin here. So now let's say that Bilbo notices some weird stuff going on, and he wants to know who created Pippin's account. Because he's like, whoa, we have this account called Pippin. So he wants this report. And, we're the programmers who built the program that Bilbo's using. So we have to create the report for him and make it all nice. So what we do is we select, let's select su1.userid. And, let's actually give them more meaningful names. So we're going to say this is the, and we'll just call it su1. su1.email. And we're going to say su2.email. We're going to call this and we're going to join that on su1.createdBy is equal to su2.system user ID. Right, and this is where context is important, because in the address one we still use the same column, but in this case it actually isn't quite as clear, which is why context is very important. So su1 is our kind of whose account we're looking at. So let's actually just call that account. And then su2 is actually the creator, right? So let's go ahead and run that. Let's see what I did here. su2 unknown column su2.system user ID and on clause system user su2. Oh, the user ID. Sorry, I just did the user ID. There we go. So in this case, our context is I'm looking at Pippin's account, and Frodo is the person who created that account, if that makes sense. So whenever we're doing self joins, like context is very important, which is why it's a good thing that we have to kind of name our columns to have them make sense. Because otherwise I just say email and email, but the column name is kind of what's going to tell us who it is. It's like I could say created by. So Bilbo Baggins was created by Bilbo Baggins. Frodo was created by Bilbo. Samwise was created by Bilbo. Pippin was created by Frodo. Cool. All right. So I will just jump gears very quickly into, I guess, let me, before I do that, any questions on joins? All right. So we'll move on. Does anyone have any, is anyone stuck on how to build their final project, or like have an idea for a final project that you just haven't roped your head around as far as how you're going to design it, or have some questions?
I do. I just saw that you got back to me. Sorry about that.
Oh, no, it's all good.
I have quite a complex idea and I have it started, but I'm not quite sure how to bring it into fruition very well.
Okay. And it's a store, right?
It's an app. And it's for divorced parents. And so basically, it's an app that tracks all the contact your child has with the other parent.
sometimes this can be court ordered and that sort of thing. But sometimes it's just good to have a record. And so I've run into a lot of people that have a need for this. And so this kind of came up as an idea. So I've got, I think, 9 tables for it so far.
Perfect. Yeah, I like the idea. So let me tell you what, I will take my stab at it. So I won't know all the functionality, but I'll take my stab at it, and I'll because I'll probably ask you a few questions here and there just about how it's supposed to work, but I'll take my stab at it, so that way I don't have to try to recreate anything you've done. I can just kind of fly through, because I'll probably do a short version. So
Yeah.
Okay, so the first thing, especially when I'm dealing with people, I always like to build a person table. And the reason being is because a person table is very basic, and it can actually be used for a lot of different things. So for example, even like in this case, you're building an app, but you're probably going to want a way for people on the back end to provide customer support, and that sort of thing. So you're going to have to build access as well, and track that. And maybe you'll eventually want to connect this to like HR software to track your own employees. So that's why I like to kind of build this person table, because we can, once we have a person table, we can then build that into whatever we want. As far as like how they track I'm kind of fleshing this out, how they track the people, I'm guessing, is it just all manual entry? Like when they kind of like, they self-record when they have contact?
Yeah.
Okay. All right. So real basic.
At this point, I assumed you'd have a communication table that just encompassed any type of communication.
Yes. So I'm going to go, yeah. So let's do. All right, so let's just leave that just like that. So our person table is going to hold everyone from the parent, the child, both parents. It could even hold emergency contacts. It could hold our staff, everybody. It just depends on how we build from here. So I'm going to build another table, because the first thing I want to do is I want to build a connection between people. So I want to build the connection between the 2 adults and possibly the child. So I'm trying to think of the right nomenclature for this. Let's do. So let's start off. Let's just build a relationship type table. Because let's say that it's, I'm just thinking out of the box here. Maybe we want to build this so any court ordered contact could be recorded. Like, let's say it doesn't necessarily have to be between 2 divorced people. Let's say it could be between, for example, like a parent. Anytime a child's involved necessarily, it could be a lot of different things. So I'm going to kind of build it under that assumption. I like to kind of always think like scope. If scope expanded, I don't want to be stuck in this box where it's like, oh, I have to rebuild everything. So that's kind of why I'm going this route. So I'm going to build a relationship type ID. So relationship type is just going to hold all the various types of relationships. So it's going to be pretty basic. It's just going to be basically like a name. And then I'm actually going to build let's see. So name, relationship type ID. Because relationships can be guardians. So I don't want to build a guardian flag here. So I'm just going to leave that one pretty simple. relationship type. Next, I'm going to build a actual relationship table. And the relationship table is going to hold the relationships between two people. So I'm going to have a relationship ID, and then I want to connect first. And I like to think this through logically. Really, the order of columns doesn't matter, but it always helps me in my brain. So the first thing I'm going to do is I'm going to put person ID in here. Then I'm going to put the relationship type ID. These should both be integers. And if you were planning on really building this to like be Facebook levels, I would probably use a big int instead of just a normal int, but it doesn't matter. Integer will work fine. That's always something you can change later. So anyways, I'm going to make those both integers because they're just going to connect. And then I'm going to build another person ID, but it's going to be for person ID 2. And that person ID 2 is going to link to the second person because obviously we can't have two of the same name. And those are all going to be not null because if we have multiple relations, if we have a relationship, two people need to be involved. And then I'm going to add this guardian flag. This guardian flag is going to be a tiny int. Basically a 1 or a 2, true or false. Come on. Come on. Work with me here. I have no idea why that doesn't want to change for me here.
It switches back unless you hit enter.
That one, for some reason, just does not want to change.
Does it have to be default to false or something? Or?
It shouldn't have to be, but I'll just put it as an int for now because technically this isn't supported on my platform. So we'll just chalk it up to that. But as default, I'm going to just put this as a 0 because I don't really want guardians just to be made willy-nilly. So I'm going to default a guardian flag to 0. So basically in our UI, whenever we would build that, I'm going to set that default. It'll be a checkbox. Hey, do you want this relationship to be a guardian? Yes or no? Yada, yada. So now I'm going to put my foreign keys in here. So the first thing I'm going to do is I'll just leave this default. Relationship 1 is going to reference person. And it's going to reference person ID. Second is going to be our relationship type ID. And lastly, our second person ID 2 is going to reference person ID. So in this case, we actually have two connections to person, one for each one. And then those have a relationship type, which basically means that, all of our relationships are marked accordingly. All right, so there's kind of like our base kind of setup for our relationships that we can kind of set up. So now what I'm thinking from here, what I want to do is for every, let's see. So we kind of want to lump together, and I'm not like a household, but not really a household because it's like, obviously if they're divorced. So I'm just trying to think of nomenclature on how I would word what I would call this thing. Let's call it let's just keep it simple. We're just going to call it a communication group. I'm going to just call this, and one of the things you'll see me do frequently is we can't have two table names be the same, but within those tables, like I could have for example, I could have a relationship group and a communication group, and both of them could have a primary key of group ID. Not going to matter too much. So I like to keep it short just so it makes sense. Auto increment. Did I set these to auto increment? No, I did not. There. Okay. So our communication group. Basically, a communication group is going to be basically a certain user's a certain way to kind of lump these relationships together. Really, it's like, so for example, to the original point of this program, if I have an issue with a certain or a divorce, like if we have to log off our communication, there's really going to be 2 people involved, maybe even 3. So what I want to do is I want to have a communication group that is kind of, I guess you could say, a combination of people all lumped together. So I'm going to give this a name. Not be null. And I'm going to give it a created by. Let's do created at. And at this point, we could throw a bunch of other columns in here as far as like, do we want to say that they can choose to make it court appointed, that kind of stuff, which I'm not going to worry about right now just for the sake of this. So I'm just going to build a communication group, which is basically not going to be necessarily tied to anything right at the moment. Basically, if like someone chooses like, hey, I want to create my creation group, it will be created by person ID. All right, so there's our creation group. One person has to be the creator. That's why I linked that up, just so we had a way to kind of say, it really is just a who audit, like, okay, who initiated this? But then also we kind of have an owner to tie it to, so it doesn't get abandoned necessarily. So next we're going to build another table. And we are going to call it communication group member. We're just going to call it group member ID for short. Auto increment it. And this one's going to be another one of those kind of utility ones where basically we're just going to have a group member ID. We're going to have a group ID, not null, and an integer. And a person ID. And again, we could add more here to kind of like say like, oh, what's their role in this, for example. And in fact, let's put a flag here. And let's say for this flag, we want them to be either flagged or unflagged as a, actually, let's build a whole nother table. Let's just do this right here. Get out of here. I'm going to build a table called a role. I don't think we can call it role because I think that's a reserved word. So we're going to say group role. Group role ID. And basically this is going to track like, cause like maybe we have like in our communication group, we have a mediator, right? Who maybe is just there to make sure that everything is is safe and can monitor everything to make sure everything's fair. I know that's kind of a thing. So we're going to give this a name, which can't be null. And then I'm going to kind of give it a couple of flags that we can use inside of our logic when we actually build our application. So like, let's say for each group role, there's certain kind of privileges that come with it. So let's say that the first one is like a communicator. The second one is like a mediator. And then maybe there's like someone who's in the communication that's just there as a, I guess you could say like the child could be a non-participant, so to speak. And so I'm actually going to just use a participant flag. And this is kind of where, this is where you get to kind of start having some fun with, like what is this going to look like at the end of the day? So I'm just going to make that an int since I have all those problems. I'm going to default that to 1 actually. Let's build a mediator flag. Default that to no. And really, like, people will never have access to this data as far as your end users. This is more for your staff to kind of manage this. This lets them create more roles as needed, right? So I'm going to say but we already have we have a participant flag, we have a mediator flag. I'm just going to leave it at that. All right, so pretty simple group role. And this is something that you could just insert all that data there and it would never change, right? It's just really going to be a drop down. So like when, I'm setting up my communication group, I'm a participant, my ex-wife is a participant, and my mom is going to be a mediator. And and this other role is going to be you can create all these roles and just flag them. So, the mediator may not be called mediator. It may be called, attorney, right? There may be a role called attorney, and that attorney may be a mediator flag. They may be flagged as participant and a mediator. The options are endless. So I'm going to leave it at that for now so I don't keep you all night because we're already almost an hour and a half here. So I will hurry. So next, what I'm going to do, because we want to get to the meat of this thing, is communication group member. Let's create a role. And this is, again, where you have to kind of make some assumptions. This is one of those parts where we could fork this. Can a group member be more than one role? For example, could they be a mediator? Could they be 2 roles? I'm going to go with what I would do and say, no, they can't. Like, a person's only in a communication for one reason. So I'm going to give them a role ID. That way they're set. They can only be one thing at a time inside of a given communication circle. But an attorney could be in more than one communication circle. Okay, so next we have our group member. Let's link those up real quick so we're all set here. First thing we want to group to is our communication group ID. And then our person. And then our group role. All right, so now we're all linked up, just like that. Next, what we're going to do is we're going to get into the meat of this, and we're actually going to build our log, right? So I'm going to actually call this communication ledger. Actually, we'll call it log. All right, and this communication log is going to really just kind of tie out all this stuff here. So I'm just going to call this a log ID, primary key, auto increment. The first thing I want to do is I want to tie this to a group member. And the nice thing about tying this to a group member is it automatically ties it to everything else. So at this point, once I'm connected to group member, I'm already connected to, because group member ID is here, I'm already connected to the person, I've got the group, and I've got the role. So I don't need to worry about anything past this point. And that's kind of why I do that. Instead of connecting this right to person, I connect it to here because, like I said, a person might be in more than one communication group, and he probably doesn't care to see his log outside of a communication group. And even if so, we could still have all that information, but it's already tied to everything else rather than have to connect it all over again. So I kind of leave it at that stage. Okay, so there's our communication group or group member ID. We want, what else would we want to log here? We want to say who it's going to. So let's say recipient. And I like to name things so they're pretty clear. I'm going to say recipient group member ID. Right, so who are we sending this message to? What time did we send it? So let's say sent at, and I've actually spent some time in the legal field, so this is actually going to be my kind of forte here. So I'm going to say that the default is a current timestamp. Let's just assume that, to make it easy on people, that if they don't want to type it in, it'll default to the current time. So sent at, I'm also going to put recorded at, because maybe we sent it and recorded it at a different time, and we want to make sure that like everything's clear about that, right? You know, at default, we're going to say that it all happened at the same time, but just to be sure, recorded at. All right, and this is where I'm going to actually put the message. Or let's say, what do we want to call this? Yeah, let's just call it a message. Message text. Right. And this is going to be a big chunk of text because, you know, it could be a whole like email, so to speak. So I'm actually going to make this a text column. I'm going to leave that nullable. It just doesn't like some of these things for some reason. Let's try a long text maybe. There we go. Okay. A long text, and then I'm going to also put notes because oftentimes, you know, you might want to record your own notes, like maybe it was a phone call. Oh, and that's one thing that we probably should do is we should probably have a, let's make this a long text as well. I actually want to try this. Yeah, it just does not like that. Long text. Okay. So the other table that we might want is a communication type table. Right. And we could add more to that. Like we could actually add like specific stuff, but you know, it could be email, it could be phone, yada, yada. We could add all these different settings to help our application with that. But for now, I'm just going to keep it simple so it acts like a drop down field. And I'm going to have communication type or type communication type ID. Going to be an int. We're going to make that not null, and I'm actually going to pull it up there. All right, we're almost there. The first thing is our group member ID. Who sent the message? And then our group member for our recipient. Then our communication type. I think that's it. Yep. Perfect. All right. So that actually is pretty close. Does that work? Does anyone have any questions about this so far?
I have a ton of questions, but I should probably save them and see if we can meet and figure out exactly how I want to do it.
Yep. Yeah.
That would be my assumption.
Yeah, because I mean, you'll probably want to build this. You probably have ideas how this should work. And like I said, I just took my stab at it, how I would go about it.
Mm-hmm.
But yeah, this is a rough draft, basically, of how I would do it. And really, at this point, I would be good enough to kind of start throwing some data in some of these places because, like I've said this before, where a lot of times you're gonna like get started and then realize like, oh, like this isn't gonna work, or
Mm-hmm.
and a lot of times you just don't realize that until you get the data in there. And that's kind of the whole point of why we build the ERD, then why we actually go through all the test cases to kind of prove a concept. But yeah, but as far as outside of like how it functions, do you have any questions about why I did a certain thing that maybe is unclear? Or anything that's
What is it when you say you flag something? What does that mean?
So a flag, like this mediator flag, really what I mean by flag is it's a Boolean. It's either on or off or true or false.
Okay.
So I like to call those flags because they're really helpful for the system. And when I put a flag in, really on the user interface, I picture a checkbox. So for example, like on in this, like I said, this table would be more on like the administrative side. So like, okay, like initially I'm going to set up my group roles. As far as how the system handles the logic on the actual application, it might be nice to know if they're a participant or a mediator, right? Because like maybe the mediator can see both people's logs, but a participant can only see their own logs, or maybe a mediator can flag a log entry or something like that. There could be certain system use cases. And same thing with like communication type. You might want to put like a message flag in there to say like, hey, if you're using email, then I want you to have a message text, like I require it. But if it's a phone call, I don't require a message text, but I require notes, so to speak. And the nice thing is it takes all like the guesswork out of it as far as like an end user, because as an end user, hey, I select, I called them. All of a sudden, hey, you know what? Like I don't see a message field anymore. I just see a notes field. So I fill that out. And, so it all, a lot of this stuff is just on the UI side of things, but
sure.
We kind of build it in here. So.
Why, I guess I don't understand how one table can connect to a same table twice.
So like in this case, like the relationship table, two people make a relationship, right? And so if I have, so for example, my case, I would be, and this is like, I come back to context, right? When I look at the relationship table, this is going to be a good example where, because a relationship can go both ways, right? Like, for example, me to my daughter, I am her father, or, she is my child. So person ID Tanner And person ID 2, Addison, the relationship type would be child, because you're going from person ID 1, which in terms of context is my perspective. She is my child. But let's reverse that, because there's actually going to be 2 entries there. There's going to be person ID Tanner, person ID 2 Addison. If I reverse that, it's going to be person ID Addison, relationship type father, person ID 2 Tanner. So just like we were talking about those addresses, we are going to have opposite entries there, but we actually want those, because it all comes down to context. Because like when I log in, I want to see my relationship to Addison is child. But when she logs in, I want her to see the relationship as father. If that makes sense. So we can link both of those, because the person IDs are going to be different and we have 2 different columns. So really we're just linking 2 people together.
So that's allowing 2 person IDs to reside in the relationship table at the same time
Yep.
that relate.
Yep. Because really the
Okay.
column will just hold
Yeah,
2 values.
that clicked.
Yep. Yeah. Because I mean, technically, really, if we wanted to, we could have person ID Tanner, person ID 2 Tanner, relationship type self, if we really wanted to, and it would all work at the end of the day. I mean, we probably wouldn't want that, but it's technically feasible.
That makes sense. This is great. This is a totally different direction than I thought it would go, but
yeah, and that's
it's-
kind of why I like
it's
to
really helpful to,
yeah, I kind of like to walk through, and this is actually a great example. I'm glad you brought this up, because probably this one is unique, which I really like, but it also had a lot of these cool design concepts that are kind of harder to wrap your head around. Like, for example, the relationship table, like where we connect 2 people. The other one that's really popular is stores, but a lot of the same concepts will come in, but hopefully it gets your mind working to like, because that's why I actually really like watching the reverse engineer videos you guys make, because you guys all do great, but at the same time, it's like, it's only week 1, so I don't expect much, but I'm like,
yeah,
this will blow your mind when we get there.
right, yeah.
And so, yeah, so I'm really glad you did this example, because this is actually a little bit more on the complex side, which is actually good, because I think, once you see it and work through it logically, even if it's something different, because like you might change this design based on your end needs, but the whole concept is to, as you're thinking about it, kind of, and that's what makes it really hard, is you got a big picture. And that's why I say, I can sit here and build this. And if that works for you, because MySQL Workbench makes it really easy to kind of like pop things in and see the connections. But a lot of times I have to like just sit down with a piece of pen and paper and kind of like I'll just draw bubbles. And so like, I don't worry about the column names. I'll just draw bubbles with the table names and visually map it before I even sit down to start thinking about columns, because, you can just get wrapped up, because like, to me, that's the funnest part. In fact, like I have a really big problem I'm trying to solve right now. And it's like, do I design it this way or this way? And I don't know, because of future implications. I could see it going either way, but eventually I'm just gonna have to pick one and deal with it. But anyways, yeah, so great example. I'm glad you brought it up. Yeah, we can connect later if you want to work through more. More than happy to do so. And same offer to everyone else, because this is actually my favorite part of the class is watching you guys build these projects. So if you want help kind of like doing this, what we did right here, a lot of times like people will say like, hey, this is kind of the idea I had. I can real quick kind of like spitball an idea out there and help get it started. And the other thing is, it doesn't have to be perfect either. I doubt this model's perfect. It's all about taking your best stab. So, even if it doesn't look complex like this one is, really at the end of the day, if it gets the job done, it works. All right. Any other questions? I know, sorry, I've kept you almost for 2 whole hours. Holy cow. But it's been good. All right. I will leave it there since we're almost at 2 hours, but definitely appreciate all you guys, all your questions. This example's been excellent. It's been awesome. I'm actually going to save this because maybe next week we'll actually start to throw some data in it and test it out. So I'll save this and we can continue kind of filling in some of these things to kind of proof of concept, like how this little relationship piece works, for example. So anyways, have a great week. If you get stuck on anything, please feel free to reach out, and I hope you all have a great week.
Thank you.
Thank-
Yeah, thank you.